Hello students. In previous video we did the topic address input output devices IO/MBAR pin. In this we learned S1 pin and S0 pin, status S1 pin, status S0 pin and input output/MBAR pin. So I hope that is clear to you. And also previous to this we had learned about different pins available in 8085. So 80 in those pins, some of the pins are little tricky to understand. So I will explain you those selected pins. One of the pin is hold acknowledge. In this topic we came across the word direct memory access. So let's see what is direct memory access. Direct memory access is a method that allows an input-output device to send or receive data directly to or from the memory, bypassing the CPU to speed up memory operations. Now, what does that mean? Input-output device, like for example, pen drive. It, for example, wants to send data to the main memory. Main memory is RAM. So if I want to access the data which is stored in a pen drive and I want that to be copied in the main memory which is RAM, and the chunk of data which I'm copying from pen drive to the main memory is huge, so that time the copying of data through processor will be difficult and time consuming. It's not difficult, but it will be time consuming. So this direct memory access method, what it does, it bypasses the CPU. It bypasses the CPU to speed up the memory operations, and also in the meantime CPU can do other operations while copying the data to the main memory. And this process is managed by a chip known as DMA controller, direct memory access controller. Now what happens without direct memory access method? If an input output device is ready, the processor fully dedicates itself in transferring the data between input output and memory. Okay? When input output device is ready to send or receive the data, the processor fully dedicates itself in transferring the data between input output and memory. It transfers data at a high rate, but it can't get involved in any other activity during the data transfer. Then what happens when I'm using direct memory access method? Let's see what happens. When input output device wants to send the data, this block, as you can see, this input output device wants to, for example, write the data into the memory. So what will happen? This input output device will send request to DMA controller. Then DMA controller will send the hold signal to the processor. So what exactly is DMA controller trying to do is it is trying to tell the processor that it needs to use the system bus. System bus, you know, there are three types of buses in 8085. One is data bus, second is address bus, third is control bus. So these three together forms system bus. So DMA controller will tell the processor that I want to use the system bus. Then processor will send the hold acknowledgement to DMA controller. It will acknowledge, it will tell the DMA controller that it has released the system bus. You can do your task further. Then once the DMA controller receives the hold request, it sends acknowledge to the input output device. DMA controller will acknowledge input output device that you can start sending the data to me. So input output device, if input output device wants to write the data, and when input output device wants to write the data into the memory, input output device will send the data to the DMA controller, and DMA controller will copy the data into the memory. When memory wants to write the data to input output device, then memory will send the data to the DMA controller, and the DMA controller will further send it to the input output device. And if input output device wants to read the data from memory, that also it can do. It can do read and write. Okay, so this is the meaning of direct memory access method. So let's see what is there in hold and hold acknowledge. Hold input pin is required during direct memory access operation. Now you know why hold input pin requires, why hold input pin is used. It is used during direct memory access operation. That is, hold signal informs microprocessor that another device requires to use address and data bus. After receiving the signal hold request has been received on the pin, hold acknowledges sent to the is sent. Okay, so I hope now it's clear to you. Next, I want to clarify SID and SOD pin. SID means serial input data, SOD means serial output data. SID, what this pin does, bit by bit, any data coming to the microprocessor is coming through SID pin bit by bit serially. So any data which is coming to the microprocessor coming bit by bit serially, and serial SOD means serial output data. If microprocessor is processing the data and giving the output, that it will show the output bit by bit serially. Then some of the pins I want to clarify. This trap, RST 7.5, RST 6.5, RST 5.5, INTR. If we'll count 1, 2, 3, 4, 5, these are 5 interrupt pins. These are 5 hardware interrupt pins. We will be learning interrupt topic in detail, but since it is mentioned in the pins we have, I'm trying to explain you in short. So these are the 5 hardware interrupts. Why hardware interrupts? Because these interrupts come to the processor through the pins of the microprocessor, through the hardware of the microprocessor. That's why this is hardware interrupt. Okay. Maskable, non-maskable, and maskable means the interrupt can be ignored, disabled. Non-maskable means the interrupt cannot be ignored, cannot be disabled. So trap is the only interrupt which is non-maskable. We cannot ignore it. The processor cannot disable it. Then there is a term vectored interrupt. Vectored means that when this interrupt, such types of interrupts comes to the processor, it knows the address of the input output device from where it is coming. It knows the address. When such type of interrupt comes, where it has to go, it knows. Okay, and non-vectored interrupts are the interrupts which comes to the processor, and processor doesn't know from where that interrupt is coming. So trap, RST 7.5, RST 6.5, RST 5.5, these 4 are all vectored interrupts. Only INTR is the one of the interrupt which is non-vectored interrupt. When such interrupts comes to the processor, then the processor doesn't know from where the interrupt is coming. Next, I want to clear the pin ALE, address latch level. If you remember the data buses of 8 bits in 8085 and address buses of 16 bit, and there are 8 address pins and 8 are address and data pins. If you remember, I'll show you in the diagram. A8 to A15. These are address pins. If we'll count from A8 to A15, there are total 8 pins for address, but address bus is of 16 bits. Then where are the other 8 bits? If you will see, along with data bus is of 8 bits, so D0 to D7, so total 8 bit data bus, and the remaining 8 addresses are multiplexed with these pins. So there are 8 pins which are multiplexed, address and data bus. So what happens is this pin carries address information also and data information also. How will the pin come to know that the particular bit received to me is address or data? That time ALE is used, address latch enable. What happens is when ALE is 1, that means the bit which is received on these pins are address bits. When ALE is 0, that means the bits which are received on these pins are data. Next, I want to tell you about clock out pin. Clock out pin is used to synchronize the peripherals of the microprocessor, the input output devices which are connected to the microprocessor. Clock out pin synchronizes these peripherals with the internal clock of the microprocessor. So I hope all the pins are clear to you. The pins which I thought might be ambiguous to understand for you, that's why I have repeated these pins. Otherwise, if you have any doubt, you can ask me in the comments. Next, today we have to start with internal block diagram of 8085. Internal block diagram. If you remember, we have already done generic block diagram of generic microprocessor. Okay, generic microprocessor. Here we are going to learn about internal block diagram of 8085 microprocessor. Okay, the figure 1.5 shows these following main blocks. The main blocks are 3 types of bus: registers, arithmetic logic unit, flags, program counter, stack pointer, incrementer, decrementer, timing and control sections. Okay, let us see the diagram first. So here what it had mentioned, it has registers, it has 3 types of buses. Can you see the buses? Then what it had? Then it had arithmetic logic unit, ALU. Here is the ALU. This is arithmetic logic unit. Then it has flags. Then it has program counter, stack pointer, incrementer, decrementer, timing and control section. So what exactly is happening as we have learned about generic microprocessor? So we do have idea of some of the blocks, I mean almost all of the blocks present in 8085. ALU, arithmetic logic unit. It is used to perform arithmetic and logical operations like addition, multiplication or AND operations. Flag register is used to depending on the output of ALU, the flag register is set or reset. Set means 0, so set means 1 and reset means 0. So what if my answer is 0? If answer is 0, then ALU will set Z flag is equal to 1. If answer is not 0, Z flag will be set to 0. So depending on the answer of arithmetic logical operations, ALU sets the value of the flag. The three types of buses, if you remember, data bus, address bus, control bus. These are the buses. This is the control bus. Three types of control bus are mentioned here. Main control bus, interrupt control bus, SID, SOD. If you remember, interrupts is something when the input output device wants to send the read or write data from the memory, for example. So input output device will interrupt the microprocessor. So this is interrupt control bus. What if interrupt occurs? The signals are sent to this bus. SID has to be serial input data, serial output data, if you remember. So serial input data, serial output data, for that also we need control bus, and for timing and control operations we need the control bus. So there are three types of control bus shown here. This is 8-bit internal data bus. If you'll see, this is 8-bit internal data bus. This is AD7 to AD0 address data bus multiplexed, and A8 to A15. This is the address bus. Registers: B register, C register, D register, E register, H register, L register, stack pointer, program counter, incrementer and decrementer, instruction register, temporary register, accumulator. This we will be learning in detail one by one. Okay? These are the registers. If we'll try to connect with what we had learned in generic microprocessor, this is somewhat same. Flags, just now I explained you. Then timing and control sections. Okay, so one by one we will see in detail. 3-bus structure. Refer figure 1.5. There are two input-output bus as 8-bit data bus and 16-bit address bus. Okay, there are two input-output data bus. One is data bus, one is address bus. Data bus is of 8 bits, address bus is of 16 bits. As mentioned earlier, AD0 to AD7 bus is address data multiplexed bus. Multiplex means one thing is used for multiple purposes. Like one bus is used for two purposes. First is to carry the address, second is to carry the data. Control bus is not shown, it's shown, but different signals are transferred to different blocks. Through control bus, different signals are transferred to different blocks of 8085 microprocessor like write, read, ALE, etc. So these signals, if you remember this, there we have write pin, read pin, ALE pin. So these signals are received by the microprocessor on the write pin, read pin, ALE pin. So where these signals are coming from? It is coming through control bus, which are generated by control section that forms a control bus. Control section is talking about this timing and control section. It has three types of control bus. One is for interrupt control. We just now discussed this, which includes interrupt controls. What it includes: INTR, INTA. If you remember, INTR is an interrupt. INTA is to acknowledge that I have received an interrupt. It acknowledges the input output device that I have received the interrupt, and the further process I will be doing. That microprocessor acknowledges the input output device. RST 5.5, RST 6.5, RST 7.5 and trap. Okay. The second one is for serial communication, SID and SOD. The third control bus is the main control bus. It generates all control signals that are applied internally and externally to execute an instruction. Now next is registers. What are registers? Registers are used to store the data temporarily. Okay? There are different registers used for different purposes. आपको मैंने I had shown you the different registers here. Different registers are used for different purposes. So let's see. Journal purpose registers. There are 6 journal purpose registers starting from register B to register L. These are general purpose registers which are of 8 bits. Okay. Accumulator, temporary register, flag status registers are special purpose registers, you can say. When accumulator is used with flag register is known as program status word. Okay. These are the different registers. B, C, D, E, H, L. These 6 registers are general purpose registers. Get it? And these 6 registers are 8-bit registers. Accumulator, temporary register, stack pointer, program counter, incrementer and decrementer. These registers are special purpose registers. And stack pointer, program counter, incrementer and decrementer are 16-bit registers. Accumulator is 8-bit register. Okay. If I want these general purpose registers can be, these are, as I had told you, that these registers are of 8-bit. But if I will use these registers in pair, the length increases, it increases to 16-bit. When I want to use B register with C register, when I will use B register with C register, it will become BC, which will be of 16 bits. Why 16 bits? Because B register is of 8 bit, C register is of 8 bit. 8 plus 8, 16 bit. Likewise D, E, H, L. These are the register pairs B, C, D, E, H, L. If I will try to do the pairing as B, E. No, it's not possible. If I'm trying to make the pairing as BD, no, it's not possible. Only B, C, D, E, H, L. Only 3 pairs are possible. B, C, D, E, and H, L. Okay. Then accumulator. What is accumulator? Accumulator is used when I want to do some operation, arithmetic and logical operations. If you will observe, accumulator is somewhere near ALU, arithmetic logic unit. What happens is, for example, there is one instruction, for example, add instruction is there. Add instruction. This is the instruction out of those 74 instructions which is present in 8085. Add, if I write B comma C, and for example, sorry, B comma C, it won't be B comma C. Okay, it won't be B comma C. Add B. What will happen is, what it is trying to do, is what is the meaning of this instruction? Let us check. For example, in B there is 7 and in A there is 2. Okay, so what is the meaning of add B? The meaning of add B is A is equal to A plus B. Okay, so what it is going to be? 2 plus 7. A is equal to, actually it should be A is equal to 2 plus 7. Then A is equal to, let us write 0 over here. 0, 2, 0, 7. B holds 0, 7. A holds 0, 2. So A is equal to 0, 0, 9. Okay, so what happens is I am performing addition operation. So the contents, when addition is performed, the result will be stored in the accumulator. The result will be stored in the accumulator. And also accumulator is used to store one of the operands. One of the operands, for example, if I am doing 02 plus 07. So here operands are 02 and 07. One of the operand will be stored in accumulator. So the function of accumulator is stores one of the operands, and also after performing the arithmetic and logical operations, the result is stored in the accumulator itself. Okay. So let us see. Accumulator is of 8 bit. You have to remember this. Accumulator is of 8 bit. It is an 8 bit main register in 8085 microprocessor. It is used for performing arithmetic and logical operations like addition, subtraction, and XOR operations. One of the operand is stored in accumulator. Now, I hope you understood. It can be used as both source and destination address. Source and destination address. Source and destination register. So I will explain you this term. For example, there is one instruction out of those 74 instruction is move, MOV, B, comma, C. What does this mean? This means that the meaning of this instruction is the contents of C will be copied into B. That is the meaning. And the contents of C will not be altered. Which means contents of C will be unchanged. So this is known as source register and this is known as destination register. I hope I am clear. So accumulator can be used as both source and destination register. The final result of these operations is also stored in this accumulator. The final result is stored in the accumulator. Accumulator also used for input-output operations. Operations like when you remember those pins, SID, serial input data, serial output data. So to serially input the data, to serially output the data, we use accumulator. Accumulator is required that time. Then general purpose registers. Let us see general purpose registers. General purpose registers, as we have discussed, there are 6 8-bit registers which can be used as 16-bit registers in pairs as BC, DE and HL pair. Okay. The higher MSB, if you remember I had told you all what is most significant bit and least significant bit. The higher MSB 8 bits are stored in. For example, I want to store 24C5. This is hexadecimal number and H represents the hexadecimal. So 24C5, I'm talking about 24C5. So 24 is most significant bits when you will convert it into binary. 24 is most significant bit and C5 is least significant bit. The higher MSB 8 bits, so and each digit in hexadecimal represents 4 bits. I have already explained you this. So these two digits will represent 4 plus 4 8 bits and these two digits will represent 8 bits. The higher MSB bits are stored in first register pair and of first register pairs, if you remember. The pairs are as BC, DE, HL. So most significant bits are stored in first register of the pair. First register. If you are using register pair BC, so most significant bit will be stored in B register. If you are using pair DE, then most significant 8 bits will be stored in D register. When you are using HL pair, then most significant 8 bits will be stored in H. LSB 8 bits are stored in other register of CEL. LSB 8 bits. If you are using register pair BC, then LSB least significant bits will be stored in C register. When you are using DE register pair, then least significant 8 bits will be stored in E register. Similarly, when you are using HL register pair, then least significant bits 8 bits will be stored in L register. Suppose a number 24C5H is to be stored in DE register pair. In DE register pair, 24 will be stored in register D and number C5 will be stored in register E. So this was the explanation of general purpose registers. Now the remaining are temporary register. We were doing the topic registers. Okay, temporary registers. This temporary register is used to store operands. You know what are the operands? When I'm doing 2 plus 3, then 2 and 3 are the operands. If you remember, I had explained add instruction. So the temporary register is used to store operands of arithmetic and logical operations. If you see the diagram over here, temporary register is used along with a arithmetic logic unit next to accumulator. Accumulator is also used to store the operands. So it's used to store the operands of arithmetic logical operations. Similar to accumulator, other 16-bit registers like program counter, stack pointer, etc. are used for special purpose which are explained below. Okay, so we will be learning in detail about program counter and stack pointer. I have already created a video on program counter and stack pointer, so there is no point for me to explain you this thing again. Just go and watch the video again. Okay, so the further topics we will continue in the next video. So in the next video I will start with arithmetic logic unit. For this video we will stop here. Thank you.